What's up guys, my name is Preston Palmer, student engineering, where my goal is to help other engineering students like me better understand engineering. So in this video we're going over how to find the moment about a specific axis. If you find this helpful, please subscribe. So finding the moment about a specific axis isn't something you'll run across very much in your education, and especially not outside of school. But I'm doing this for you guys just in case you might come across it, or you're preparing for a test and it's going to be on there. So there's two different ways to solve for the moment about a given axis. There are the scalar analysis and the vector analysis. And the way you do that is, if you're using the scalar analysis, you're going to find the magnitude of the moment about axis A, we'll call it, by multiplying the magnitude of the force by the moment arm, and we'll say sub A, but we're not going to confuse that moment arm with being in the direction of A, but rather it's going to be perpendicular to the direction of A so that it can cause a moment. So the part of the moment arm that matters is the part that is perpendicular to our moment axis. And so there's going to be a plane created by our force F, and our part of our moment arm is going to have a plane that is perpendicular to our moment axis. And so this way can be a little bit tricky because you're finding how much of your moment arm is perpendicular to your moment axis, and it has to be in that plane, so that becomes a little tricky. So the other way you can do it is using vector analysis. And that's done, and you're finding the magnitude of the moment again by multiplying the unit vector that is representing our moment axis dot our moment arm as a vector cross our force that's also represented as a vector. And that can be written out in a 3x3 determinant as the x component of our unit vector, and our y component of our unit vector, and our z component of our unit vector, our x component of our moment arm, our y component of the moment arm, and our z component of the moment arm, and our x component of our force, the y component of our force, and the z component of our force. Alright guys, so that might look a little bit nasty. You're taking the dot product of the cross product and you're getting this weird looking determinant, but I promise it's not as hard as it looks. You're just basically multiplying all these together in the cross product form, but what you end up with, as you can see, there's no direction in there, so you're just going to end up with a scalar value. And so this method is called the triple scalar product, or the scalar triple product, whichever one you want to call it. But you're basically multiplying all three of these together and you're getting the magnitude of your moment. So if you forgot how to solve a 3x3 determinant or a cross product, you can check out my cross product video up here. I'll leave a link. But basically what you do is you multiply this, and you'll cross out this row and this column, and you'll multiply this by this minus this by this. And you'll do that for all of those. And at the end of this video, I'll leave a link to an example problem we're going to do in another video. But another thing we need to note is that if our magnitude of our moment comes out negative, we know that the moment is going in the opposite direction of our unit vector. And another thing is that if we want to find our moment in vector form, all we need to do is multiply the magnitude by the direction, and we'll get our moment in vector form. And written out, that looks like our moment about axis A is equal to the magnitude of the moment times by the unit vector representing that axis that we're calling A. Alright guys, that's it. That's how you solve for the moment about a specific axis that you're given. And you don't need to worry about this too much. You're not going to come across it a whole lot, but this is how you do it. I'm going to go over an example problem just wait for the link at the end of the video. And if you have any questions or comments, leave them down below. And if you like this video, share it with your friends, and don't forget to subscribe.